Hi, I'm Jack Drescher, and I'm going to be speaking about the increased protection of Caribbean corals. Now, coral is essential to the Caribbean region, as not only is it vital for Caribbean ecosystems, but it's also essential for Caribbean economies. Caribbean economies depend on tourism more than any other region in the world. And as this tourism is facilitated by boating, snorkeling and diving, beaches, and fishing, these are all facilitated or protected by coral. Now, despite all of coral's benefits, it's under significant threat from climate change. According to Kenneth Anthony, the Environmental Strategies Director at the Australian Institute of Marine Science, both rising temperatures and ocean acidification are jointly the greatest threat to Caribbean corals. Now, first, ocean warming is caused by increased carbon emissions, which traps heat, and this is expected to cause a 1 to 3 degrees Celsius increase by 2100. And this is the biggest increase out of any global warming event ever recorded. Now, this will cause coral bleaching, which is the process in which algae will leave its coral host. And since algae is coral's main food supply, if the algae does not return, which most of the time it does not, then coral will die from starvation. Now, the next threat is ocean acidification. Ocean acidification is again caused by increased carbon in the atmosphere, which will react to water to create carbonic acid. Now, carbonic acid will lessen the pH of the ocean, which will lessen calcification rates. Now, calcification is the process in which coral polyps, as seen here, will build upon itself to create a healthy coral skeleton. But because of ocean acidification, erosive forces will prevent coral growth. Now, these effects in total have caused about half of all coral cover to disappear since 1957. And with all of these threats and adverse effects considered, it brings me to my question: how should Caribbean coral best be protected from the adverse effects of climate change? Now, my topic is linked to the stimulus material as it relates to urban species and urban evolution, and how they are resilient and have adapted to the adverse effects of climate change, and to Haitians who displayed resilience to their adverse situation. And it also connects to themes of survivability and survival in both of these texts. Now, going into my potential solutions, I fit into 3 main categories, which the first is reef management. Now, as you can see on this map, the red dots represent all of the protected marine areas or reefs in the Caribbean. Now, there are many more reefs than are red dots displayed on this map, which shows that there needs to be more protections in the Caribbean. Now, there are many different kinds of reef management, but the one I'm going to be focusing on is marine protected areas, or MPAs. MPAs increase coral cover after about 38 years, which may seem like a long time, but compared to unprotected reefs, which will decline consistently over this time period, it is a great solution. And effectively managed reefs will even further lower this number. Now, moving on to transplantation. This is the process in which coral will be grown in either a lab or nursery, then transplanted into reefs in need. Now, this significantly increases coral cover, and many organizations already practice transplantation, so it would be very easy to further implement. Now, the issue is it does need to be implemented alongside reef management, because if you transplant corals into unprotected reefs, then they will continue to die and it will be all for nothing. Now, there are 2 types of transplantation, the first of which is coral gardening. Now, coral gardening is the fragmentation of coral and then taking this piece of coral and moving it, again, like I said, to a reef in need. Now, as you can see here, it can only be done with staghorn coral, which does not create a lot of biodiversity. It even lessens biodiversity in reefs. And since reefs with higher biodiversity often have higher survivability rates in coral bleaching events, this is a significant limitation. Now, moving on to larval seeding, this is the process in which coral eggs and sperm are gathered from reefs with high heat of resilience and then taken to a lab, like I said, and repeating the process. However, on the contrary to coral gardening, this ensures coral diversity, as it can be used with many different species, so essentially it can improve the survivability of reefs. Now, moving on to adaptation, as provided by the stimulus materials in urban evolution, water fleas were seen to be more resilient to higher temperatures, which is very promising for coral polyps, as both water fleas and coral polyps have very similar biology and both depend on algae to survive. However, since rising temperatures are rising at such a significant rate, we can not only depend on the natural adaptation of coral. Looking at this heat map of the world, you can see in the Persian Gulf, they have the highest temperatures out of any marine area. Now, this has led Bernhard Riesch Bernhard Reed, a professor at Nova Southeastern University of Natural Sciences and Oceanography, to look at Persian corals, which display a higher resilience and heat tolerance to these high temperatures that other corals do not. This has led him to advocate for a transplantation of corals in the Persian Gulf to the Caribbean to provide a solid base of resilience to high temperatures. Also, Eric Cattell, the environmental monitoring president of the National Oceanic and Atmospheric Administration, has done research on the increased feeding rates of coral and found that increasing the feeding rates of coral can mitigate the adverse effects of ocean acidification by increasing calcification rates. Now, this will be much easier to implement in lab settings and harder to implement in site, in actual reefs, but it will be a nice short-term solution. Now, looking at my potential solutions, I have synthesized these 3 solutions to best protect Caribbean coral against the adverse effects of climate change. Now, as you can see, increased MPAs and better management of MPAs will help implement increased feeding rates and the larval seeding of Persian Gulf corals. And Persian Gulf corals will address the effects of ocean warming, while this will address the effects of ocean acidification. Now, looking more at my solution, again, a strong enforcement of MPAs will be a significant long-term solution to further protect corals in the long term. This is also a long-term solution, but not as significantly long-term as MPAs. And the increased feeding rates of introducing lipids to Caribbean corals will be a short-term solution to improve ocean acidification. Now, this implication, as I previously mentioned, has an immediate impact and a long-term impact, and it will protect against both warming and acidification, and it will increase previously lost coral cover and improve it. Now, the biggest limitation of my solution is it does not address the cause of this issue. What this means is I did not address the increasing of carbon emissions. This is just because it would be very improbable to significantly lower carbon emissions in a timeful manner, as many have tried but failed, and so I just did not consider this for my solution. In conclusion, I would advocate for increased marine protected areas with more effective management, a larval seeding of Gulf corals, and increased feeding rates of Caribbean corals. This will overall help lessen the effects of climate change while protecting Caribbean corals. Thank you, and here are my sources.
Jack, how did your research question evolve as you moved through the research process?
Yes, so originally I was focusing on just coral reefs in general, which included, various fish and other marine species, but I felt that was just too broad and it covered too much. So I then narrowed it down to coral, and then I was going to focus on the Great Barrier Reef and Indo-Pacific corals, but because Caribbean corals are like the least protected corals in the world, I decided to go with those corals.
And what additional questions emerged from your research, and why are these questions important?
Yes, one question is how to further implement marine protected areas. For example, the Glover's Reef in Belize was a successful one, but I wanted to further know how to implement, collaboration among like the United States government, because the United States government has like the least amount of protection on the reefs in the Caribbean. So a question that I would have is how to get the United States and non-government organizations to collaborate to better protect reefs off the coast of the United States.
Thank you.